Hi, everyone, and welcome to Spotlight with Scientists in School. I'm so excited today to be joined by Will Richardson-Little. Will is a senior systems engineer at MDA, and MDA is a Canadian aerospace company, and they have engineered both generations of the Canadarm. Currently, Will is working on MDA's Chorus satellite constellation. We have a chance to talk about that. Also, his life as a mission controller with the Canadian Space Agency, life on Mars, why space exploration is important. There's even a chance to talk about Star Trek: The Next Generation. It's a conversation you don't want to miss, so let's head on over and meet Will, who joins us today from British Columbia. Hi, everyone, and welcome to Spotlight with Scientists in School. I'm so excited today because I am joined by Will Richardson-Little. Welcome to the show.
Thank you very much. It's great to be joining you here.
Well, if you look at the website on NASA, it says that curiosity and exploration are vital to the human spirit. Would you agree, and would that describe you as a child?
I would definitely agree. I think I was curious as a child. I think all kids are really curious. I've got a 5-year-old daughter, and she's just curious about everything. Of course, I tell her lots about space, and she just wants to learn more and more. Recently we had the Perseverance lander. We saw that land on Mars, and she just thought that was amazing. And we told her all about how Perseverance will eventually be involved in a sample return mission. And so she ran around and she would pretend to be Perseverance and would make samples. And then I would have to be the sample return mission and go pick up those samples. And so I think that, kids are curious, they love stories. And so we can, find ways to sort of connect these stories with their curiosity and help build that. And I think the other thing too is just, how do we sort of maintain that curiosity in kids into their adulthood? Because I think they're naturally curious, and sometimes we sort of lose some of that curiosity as we get older. So let's try to keep them curious.
That's right. That's really a good point. I also find that we're constantly telling kids to be curious, to explore, to get outside with nature, all great things. I find sometimes the M in STEM is missing. So STEM is science, technology, engineering, and math. There's actually a lot of math involved in aerospace engineering. When did the math all come together for you, and when did it make sense practically?
In all honesty, I don't think there was sort of one moment. I think it's a progression. I really think that math is something, like really all things that we learn based on foundations and building blocks. And I think that, it's a progress of, you learn some aspects of math and you kind of put those together with practical applications, often through science classes. But really then you move on to the next part and you think, wow, this is confusing, this is new. And sometimes it takes a while then for that to all click. And that really continues. It continued for me through high school, through university. It does get to the point where, you've practiced so much, you've built a foundation of knowledge in mathematics that it does get easier and you start to put those connections together. But I really think that it's something that we need to think of not as like, hey, at some point you will kind of get it, but that you're continuously learning, continuously building that foundation of knowledge in math.
Right, continuously learning. I always say the most important thing we can do to our kids is make them lifelong learners, right? Yeah. So just to enjoy, to constantly learn, constantly ask questions, like you say, and be curious adults. Now, you work for MDA, right? That's That's Canadian right. Aerospace company.
That's right.
And they actually built both generations of the Canadarm, and I read that they're building the third one right now.
That's correct.
I found it pretty amazing that they were responsible for the first robotic handshake in space. That's pretty awesome. Now, you were involved with that project. How did that come to be, and what was that like?
Sure. So I was really fortunate. I was in university right around the time of that robotic handshake. So that robotic handshake was when the Canadarm2, which is the big robotic arm on the space station, on the International Space Station, was brought up to the space station by the space shuttle. And the way that worked, it was brought up on sort of a pallet inside the space shuttle, and it was all sort of folded up to make it fit in the space shuttle. And the Canadarm on the space shuttle, it plucked it out of the payload bay of the space shuttle and brought it onto the space station. And then actually that was a mission that Chris Hadfield was on, and he went out on a spacewalk and helped to unfold the Canadarm2 And then once the Canadarm2 was all unfolded, it was able to grab onto that pallet and give it back to the Canadarm on the space shuttle so that it could go back into the payload bay. And so my involvement with that was that I was a student in university at the time, but I was part of a co-op, or I started a co-op program at MDA's Brampton facility, and that's where they built the Canadarm, first Canadarm, the Canadarm2, and that's where they're working on the next generation of the Canadarm for the Lunar Gateway program. And I started only as a co-op student, only weeks after that mission to install the Canadarm2 on the space station happened. And so it was this incredible dynamic time. All of the engineers there were just thrilled. They were getting data from their arm that they'd been working on for years on the ground, has just gotten to the station. They're getting all this data. We had so much to do, and as a student, it was just great for me to be learning from all of these senior engineers. And I could just dive into lots of different things and all this data from the arm. And so that's really kind of where I got my start as an engineer.
That's a lucky, great start, isn't it?
It really was. I was quite fortunate in the timing of that.
Absolutely. I've been watching a lot of YouTube videos, and all of it's fascinating just seeing what happens in space. It's absolutely incredible. Now, you have a master's in aerospace engineering, and you were also offered a job at the Canadian Space Agency as mission controller. If a kid's watching, how do you explain what you do as a mission controller? What does that mean?
Sure. So after I did my master's, I started with Canadian Space Agency. I ended up working with them for just over 8 years. And one of the things that I did while I was there was work as a mission controller. And so this was an opportunity I had to where Canada, as part of the International Space Station program, and we provide the Canadarm2, Dexter, which is the sort of two-armed robot. But as part of that, we also have a contingent of Canadian Space Agency employees who work embedded with their NASA counterparts in Houston, Texas, at the Johnson Space Center, to work as mission controllers on the robotics system. And so I got a chance to be part of that. I went down to Houston, Texas, and worked and trained at the Johnson Space Center. And a lot of what that involved was, there's one aspect where we wrote procedures, the robotics procedures, to be executed by the astronauts on the space station. Then the other aspect of that was to actually work on console. So when you see mission control in Houston, there's sort of the main mission control room, but then there's also these back rooms where they've got additional engineers back there. And so as a mission control, I started out as what they call an MSS task officer and then an MSS systems officer. And these are sort of the backroom positions that support the robo officer in the front room. And so part of that is actually also controlling the Canadarm from the ground. That's one of the sort of newer capabilities that they have, is that the Canadarm2 and the rest of the robotics can be controlled from the ground. So we're actually sending commands and watching it move on the monitors and doing various different maintenance tasks, moving equipment around. And so that was a really amazing experience and a lot of fun.
Now, I find like to have a successful space mission, there's so many moving parts. There are so many people that have to be involved, not only to get the team there, but to get the team back. How do you keep it all together? How do you get so many people to work on the same task and have it all happen with so many moving parts?
It's really tricky. I mean, you need to have good leadership and folks who are almost dedicating themselves to organizing the rest of us and keeping people on schedule and making sure that all the different things that need to be done are getting done. And that helps folks like me who are maybe more focused on a specific area sort of just do that one job and know that there's someone else in another part of the organization that's doing their job and getting that done. And of course, you're constantly interacting with the project managers and the project leaders who are working on this. In the case of mission control, you're working with the flight directors and the other folks around there who are managing other parts of the system. But it's difficult. These are huge systems and huge organizations. And I think that the knowledge that you've got so many other amazing and competent and smart people working for you allows you to sort of say, okay, I'm going to do my little thing and I'm going to do it well. And that's going to support the rest of the team.
Yeah, I guess you all have that same common goal. Like you want to see this be successful. It's sometimes I kind of giggle thinking it's a little bit like a movie where people only talk about the actors, but to get a really great movie, there's a lot of people behind the scenes that, you know, have to work together to make that happen.
Absolutely.
Yeah, yeah. Now you, in your career, must have seen a lot of space launches. Is there one that stands out in your mind?
There is. So as part of working as a mission controller and going down to Houston, I got to work on a couple of space shuttle missions, and I worked to help write some of those robotics procedures. And part of that is to help train the astronaut crew to use those procedures when they're up there. And so as part of that, you get to know some of the astronauts, and that's a really great experience. They're amazing people. They're really fantastic to work with. But then, of course, you start to feel like you're quite good friends with them. And then I went to go watch the launch of STS-131, and that was one of the final space station assembly missions. And of course, that was one of the missions that I'd worked on. And so I knew those astronauts who were on board, and going to Florida to watch it, you kind of think, wow, this is a bit different. I know those folks who are on there, and I can really imagine what they're feeling like inside the space shuttle as it launches. And it's really nice because you kind of know how much how happy they must be to be launching off into space, and how thrilled they must be. And it's really a neat feeling to know the people who are on board the space shuttle.
Oh yeah, absolutely. Now, have you ever considered flipping roles if you could? Would you want to be the astronaut?
That's a tough one. I think I'd love to go into space. I think I've seen, being an astronaut is a huge job. It's a huge commitment, I think. I've been lucky in my career to have a variety of things that I've done, and some things outside of my career that I enjoy doing. And so I think that I'd love to go into space and maybe let the career of being an astronaut to someone else. But I will say this as well. I was fortunate in my time at CSA to be involved in the astronaut selection process, one of the astronaut selection processes. And I was just had a minor role where I was administrating some tests to some of these astronaut candidates, and they're just incredible people. Each one of them that came through had so much talent, and it was really quite incredible. And so I think that I'm not sure I could quite stack up to those folks. I was just blown away by how incredibly impressive they were.
Yeah, yeah. I would never pass the test to be an astronaut. I kind of would just want to go along for the ride, right? Like just be in the passenger seat.
It's becoming more and more possible these days. You've got these tourist flights happening and such.
Yeah, that's incredible. Do you have a career high? I know you still have a long, long career ahead of you, but do you have a career high to date?
Absolutely. So after my time at the Canadian Space Agency, I actually came back to work at MDA about 6 years ago, and I now work out at our out in British Columbia. And what we do at the MDA facility out here is a lot of Earth observation. And so we're what we call the mission prime on the RadarSat constellation mission, and this is the Canadian Space Agency's most recent big radar Earth observation mission, and that launched in 2019. And so my role on that was in what we call operations development, and I was specifically responsible for the developing the operations and the procedures and everything around what we call the launch and early orbit phase. So this is the immediately after we launch the satellites, when we make contact with them, what we have to do to get them safe and to start to operate them. So deploying radar panels and deploying solar arrays. And so I got to be the shift one flight director for the RCM launch. And I'll have to say that launch day was incredible. We had 3 satellites on one launch vehicle, and we launched them on a Falcon 9 rocket, and it had cameras on board. And so after the launch, we were all in mission control watching the launch, and we got the video and watched each one of our satellites detach from the launch vehicle and start to drift off into space. And And that was something to sort of know that, okay, now it's on us as this operations team that we built up at the Canadian Space Agency. So we operated them out of the Canadian Space Agency. And that was just an incredible experience to sort of see those go. And then the rest of that day, as we made contact with the spacecraft, we verified that they were in good working order, and we kept working through our procedures. It was just a complete whirlwind and an exciting time. And I think what really struck me at the end of that day is that we brought together this big multidisciplinary team where we had people from MDA, from CSA, from some of our subcontractors, Magellan Aerospace in Winnipeg, SCD, who are resident at the Canadian Space Agency working on operations. There are folks in Natural Resources Canada who are operating our antennas that talk to the spacecraft. We had this huge team, and we'd all come together to make this all work and make this all happen. It's just an incredibly sort of career satisfying day when something like that works so well.
Absolutely. It sounds incredible. I'm so fascinated with space and what we've accomplished. What do you say to people who ask whether we should be spending all this money, like if it's worth it? Why should we care about space exploration?
I mean, I think what I'm certainly working on right now is a lot of Earth observation missions. And I think that I'm really seeing a lot of those applications and how we use those to affect our daily lives. We recently had a lot of flooding here in British Columbia in the Fraser Valley. And immediately after that flooding, we were using the RadarSat Constellation mission and RadarSat 2 to take images of the Fraser Valley. And one of the things that using radar satellites are very good at is imaging water and imaging flooding. We do this as part of the daily operations of the spacecraft, is looking at disasters around the world and trying to take imagery of that and use that imagery to then help with relief efforts. So I think that certainly there's a very direct connection between those Earth observation missions and how we can help people here on the ground. But when it comes to space exploration as well, as you said, at the start of this, curiosity is sort of essential to that human spirit. I think there's a huge value in just learning more about our Earth, learning more about the solar system, and really, when it comes to the expense, some of our robotics missions are really, they seem quite expensive, but the amount of science that they can do when they're out there compared to that cost is really quite a valuable thing. So I think that it's still worth it.
Oh, I agree. I agree wholeheartedly. Do you think we'll get to Mars in our lifetime?
Maybe. It's a huge challenge. I think it's not a challenge to be underestimated, especially when we talk about sending people there. It's very difficult to keep people safe in space, especially when we go beyond Earth, the sort of protection of near Earth or of low Earth orbit. So it's a huge challenge. And I think we're certainly taking steps in that direction, but there's a lot still to be done. So I'd say probably. Yeah.
I have a lot of young kids that are very excited to get to Mars.
That's right. And you know what? They may well be the ones who are the first ones to go.
Hey, it might be your 5-year-old daughter.
It might be. It might be.
What other space projects get you excited these days? Anything else you're following?
Absolutely. So, I mean, here at MDA, we're working on a new mission called Chorus. This is sort of a follow-on to our RadarSat 2 mission, and it's another synthetic aperture radar satellite. These are our radar satellites that can look through clouds, so they don't need to worry about lighting conditions. They're very good at seeing ice, so we do a lot of ice monitoring with them. But this new Chorus mission that we're working on here at MDA is really interesting because we're going to have 2 satellites in a constellation where there's going to be one satellite that can take a really wide image, and so a really large sort of footprint of the image. And then we'll have a satellite that's following behind it that can take much higher resolution, smaller images. So if we see something in the big image, we can then tell the spacecraft that's following us, hey, take a closer look at this. And so it's a really interesting new mission that we're working on here, and it's really quite a fun challenge to be involved in. So that's one of them. And another one that I'm quite interested in that is still in the early days of its sort of mission development is something called Wildfire Sat, and it's a spacecraft that will be able to monitor wildfires in Canada. And so that's something, again, in British Columbia, we've had wildfires over the last number of years. And so it's really interesting to see a satellite that's going to come out there and really try to help with that. So that's a really fascinating mission that I've been lucky to be involved in.
Yeah, it's totally fascinating. Yesterday, I needed a bit of a pick-me-up, and you might find funny what I did. I actually went on YouTube and watched Chris Hadfield singing in space. I was like, yeah. And still it caught me. I watched the full 5 minutes and I was like, this man is such an incredible ambassador for space. He got the entire planet excited about science that was happening, in the ISS. He's incredible, right? Very inspirational. And I'm wondering who inspired you, if you had someone throughout your career that you looked up to.
I think I've taken inspiration from many of the engineers that I've worked with along the way. As I said, when I first started at MDA as a student, I was really lucky to have both started at a really interesting time, but I was also lucky to have joined a group of engineers where there were senior engineers in that group that were so willing to take a bunch of young students who were enthusiastic, but really didn't know anything about what they were doing. And were willing to take us and show us, be mentors to us, and show us the ropes. And I think that's where I found a lot of the inspiration throughout my career, is the people sort of close to me who've been so generous with their time and expertise. And I certainly had folks in those early days as my mentors who would, they would see something happening, like if we were doing some testing of a joint on the Canadarm 2, spare Canadarm 2 joint, they'd come and find me and say, hey, come on, let's go figure this out. And so I think that certainly when I think about my role as a more senior engineer now, I'm trying to think, okay, how can I help some of these younger students, or both students and younger engineers, and try to help them move along. But when I do that, I think back to my experience as a young engineer, and I think back to those folks who I worked with who were so inspirational to me. And I think they just demonstrated how to be a good engineer and how to conduct themselves. And I think that's something that, that's lasted with me for the rest of my career.
How about your daughter? Is she inspired by Chris Hadfield?
We've shown her a lot of Chris Hadfield's videos from the space station. And I think it's really interesting how some of those videos just connect with people and, connect with young people, especially just sort of the day-to-day living on the space station. But, she loves music and she loves singing. And so we've shown her some of his music videos and she just loves that. We've played that video countless times and now she has it memorized. So she'll run around the house singing Space Oddity. Yeah. And she just loves that. So we'll see if she ends up singing in space herself one day.
Exactly. I know. I saw it had 50 million views yesterday. Maybe your daughter's racked up a few of those.
Just a few, maybe a million or two.
Now, I didn't need to ask you whether you're a Star Wars or a Star Trek fan. I knew you'd be a Trekkie and a TNG fan. So was my husband. He loved, I don't know if you own this book, The Nitpicker's Guide to the Next Generation. My question is not whether you like Star Wars or Star Trek. My question is, if you were going to pick a captain for a spaceship, would you pick Jean-Luc Picard, or are you picking James T. Kirk?
Oh, I mean, I grew up on Star Trek: The Next Generation. So really, I think I'm a Picard guy. I really, that was what I grew up with. But really, more than the captain, I think what I loved watching Star Trek was, Geordi, the chief engineer, and Data and Wesley running around solving these engineering problems, to save the day. I think that's really one of those things that I loved and connected with, and still enjoy when I rewatch Star Trek these days.
I rewatched an episode last weekend and they made me chuckle. The episodes still hold up. They got a lot of great science in them, right?
They sure do. They sure do.
Well, this has been so great. Totally inspirational for me. And I know kids who are going to tune in are going to love this. Thank you so much. Thanks for joining me all the way from British Columbia as well.
No problem. It was my pleasure.
Great. Thank you so much. Take care. Bye.
Bye.